it continues to say that the question that we came here for, and then let me just write this answer here of saying 19.8844 watts. So now let's continue. It says that switch S is open. We open this switch. So let's open the switch there. Let me wrap here so that we work. When we wrap here, we'll find out that now, okay, when we wrap here, we are also gonna find out that now this switch is this one is not working, because what they say, this switch is open now. It's open like this. This one is not working, meaning that it's gonna alter the current passing through here. So now the question is, if now this switch is open, and then this it means that indirectly they are saying that they are removing this resistor. So because they've removed that resistor, they're saying that what will happen to the brightness of that bulb. So just know that the brightness is directly proportional to the power. If the power increase, we use the power to determine the brightness of an item. That's what we use. We use the power to determine the brightness. So now it's a way of calculating the power. If like you don't trust your answer well, you can calculate the power, and then you therefore conclude that now the brightness has changed. So let me wrap this. So now you can calculate the power before and after and show them now that this is what happened now. Here they didn't say you don't use calculation, so you can definitely use calculation to explain in 8.3.1. So in 8.3.2. So now other one says without using calculation, but here they didn't specify, meaning that you can use calculation, choose whether to use calculation or not. I'm trying to I was checking the chat if there is any question there in the chat. So now let's continue and go straight to this. I hope okay, just the cable. And then it says that increase, decrease, or stay the same. We don't know yet. We have to conclude. We are concluding with the reason. It's funny that they want you the answer on the top, and then they say that what will happen with the brightness. We first come in first reason, and then the reason will conclude for us. Will conclude for us to say that, oh, it's increase, it decrease. So the reason will conclude for us. Explain the answer of saying 8.3.1. So now when we go to our diagram there, 8.3.1, it says that what will happen to this brightness. So the first thing is that the principle that guides all this, what will happen to the brightness of this bulb if the switch is open, meaning that we have removed resistors in parallel. The principle that guides is that when we remove resistors in parallel, total resistance increase. Total external resistance increase. When we remove, vice versa, when we add resistors in parallel, total resistance does what? Decrease. So you can even understand it maybe by this simple circuit. Let me draw a simple circuit for us to understand and grasp that, because they are like inverse, adding and removing, and the total resistance. So let's say this one is 3 ohms, this one is 3 ohms. Now if we find the total equivalent resistance of this, it will be a 1,5 ohms, using that formula of Rp equals to R1 times R2 over R1 plus R2. How did I find it? I just it's half. If we use the same number, it gives you half. So now if this is the total equivalent resistance across the parallel, if we remove this resistor, the total resistance is going to increase, because now we'll be left with only this 3 ohms. And then what it will be, the R total, Rp or R total will just be 3 ohms. And then what is R here? The R is 1.5. So you see that we removed, but the total resistance did what? The total resistance increased. So it's like the inverse of one another. So that's the guiding principle. When we remove the resistors in parallel, total R total decrease. we removed it increases. We said they are inverse. R total will do what? Will increase because we have removed. R total will increase. That's the first step. We haven't concluded 8.3.1. We are going to use the reasoning to go back. So, and then you continue with your reasoning to say that if always the R total increase, therefore the current of the circuit decreases. That's the current. Why? Is because current is inversely proportional to what? To resistance. We are still reasoning there. We are still reasoning. And then now, wait, because current has decreased, you also have to say how that affect the voltage, the V lost and the V internal, because there's V lost, there's V internal. So now, if you look at the equation for V lost and and also V internal or V lost here, you can also say V internal plus V external. So now this is going to be equivalent to I. This is going to be equivalent to IR. It's going to be equivalent to IR, and then this is going to be equivalent with what? This is going to be equivalent with. This is going to be equivalent with IR, the capital letter R, R external, R internal. So now, before the the voltage goes outside, it's taken by what? It's taken by the V internal. Before the voltage it goes outside. So the V internal is the boss, because you can't it takes the voltage and there's nothing you can do about it. So it's like the boss, because it's the one that determines the V external. Is the one that determines the V external because it takes first. So first, before the V external goes, it takes the voltage. It's like the power dissipated in the voltage dissipated, or the voltage used in the battery before it goes out. So now let's get back to this equation. So it's going to take first from the EMF. EMF is constant, and then EMF is constant. EMF is constant. Is constant. It's very much important point, because it's the one that if it was changing, it wouldn't be like this. But now, because let's see what will happen to the V lost. V lost equals to IR, and we had that the current decreased, and then the V equals to IR. It means that if the current decreases, the voltage will also decrease. The current decreases, the voltage will also decrease. We're talking about V lost because this R is constant, this internal resistance is constant. Therefore, now this one will also increase. So now you'll say V lost will decrease. And then you can also mention a reason. They will just come and choose what they want to mark here, because you might find that now in the memo there are marks for different things. So then you say R is constant. I'll show you the most important points, but now you are building here. We are getting to the brightness of the bulb here. So now when we continue here, if this one has decreased, it means now therefore V external will increase, because less voltage will be spent inside the battery. It means that there will be more outside. So like how a less number will be subtracted from the EMF, there will be more outside. So now you just come and say V external, that's what V external is going to increase. So this is going to be your determining factor. This is going to be your determining factor of saying that what is power? Power equals to V squared R. Therefore, let's check. If this has increased, this will also increase. Therefore, you'll say brightness is power is power. That's why when you buy light bulbs, they'll be written 50 watts, 100 watts. And the greater the watts, the greater it lights up. So that's also what you have to keep in mind. Brightness is power, or directly proportional to power. You'll say brightness is what? Brightness, you can write it in many ways, is directly proportional to power. And then you continue to say that, therefore, power increase. If you write an equation, power equals to V squared R. How someone would be asking, how about those other equations of power? What do we make of them? So there's also this power equals to I squared R, this one. So this one needs you to first see this current. Note that, let me show you, because some students make the mistake here. They make the mistake here. Let me show you where some students make the mistake. They make the mistake here to say, now, if the current decreases now, they will come and say, oh, because the current has decreased here, it means that current has decreased, therefore power decreased. No, 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 no. What is this current? This current here that we see up here, the current that we see is the current, the total current, not the current across this bulb, is the total current. That's why we are not supposed to conclude from here, from this step of saying that because now total resistance has increased after removing a resistance in parallel, now because the total the current has decreased, therefore it will lead to this equation saying current decreases, power will also decrease. So that's not how we do it, because this is measures the total current here. If they had said that what will happen to the reading of A1 if this happened, you could end your answer here. You could end your answer here, and then you'll get your marks. You'll get your marks. But now, what will happen to the current across this? That's how we can use this equation if we solve the current across this. So now, if you check this, now the first current was divided. It goes to this branch and it goes to this branch. But now, if this branch is removed, we'll see that no, this one will end up getting total current. It will end up getting more current than it was getting before. Therefore, because the more current has increased, this one will also increase. But we don't use this, which measures the total. Actually, you must say total here. You must say total. That's why I said R total. R total and I total. So you must know where to end. But if they were saying this one, you could be correct, because this is the total of or across this one. So that distinction is very much important, because if they had also seen what will happen to the voltmeter over here, to the voltmeter reading, if this one is removed, you will end your answer here. You will end your answer here to then say, this is my answer. You say V external will increase because the voltage across this will measure the V external. So you have to know how to differentiate. So you see now I've helped us to understand the ammeter reading, or the variables of this one, and the voltage variables of the total circuit. So you must know how to differentiate. Is very much important. And then now it means that because we have gotten our answer to say brightness increase. So the answer is what? 8.3.1 increase. So this, the funny thing is that this is the paper that I wrote. I wrote this paper in metric. So I remember when we got out of the exam, I was arguing with this guy. It's increased. And then he said, how do you know? I said, we used this reasoning. And then I remember after writing, because I still had time, I finished early, I went back and calculated the power before and the power after, and then I just confirmed what I had written. So you can also do this if some say without the use of calculation, but this one there's not that restriction. So you can choose whether you want to use calculation and choose whether you don't want to use calculations. So if you have any questions, you can come in. If you don't have any question, it's fine. So now let's just continue.